All right, today we're going to talk about mixed numbers. And so a mixed number, oh, that's not what I want to do. Hold on. A mixed number, I want my shape here. All right, so a mixed number is if we have a fraction. So here I've got a whole, and I'm going to take my whole and I'm going to break it into 4 pieces. And I know that each one of these pieces is 1/4. Well, sometimes, let me draw another one. Sometimes we have more than one whole. So here is another whole, and it's also going to be broken into 4 pieces. And so same thing, each part is still going to be 1/4, 1/4, and 1/4. All right, so let me get rid of all this. So if I shade this in to show how much I have, I can show that I've got this, that's 1 part, 2 parts, 3 parts, 4 parts, 5. So I can show that this green part right here, I can count the number of pieces. So there's 1, 2, 3, 4, 5 parts. And my denominator, the denominator always is how many parts the whole is broken into. So I can either look at this whole or I can look at this whole. It doesn't matter. They both have 4 parts. This one has 4 parts. This one has 4 parts. Okay, so my denominator is 4. So let me make some room over here. So the way that I've written this, 5/4, again, the 5 comes from how many of these parts that I have here, and the 4 represents how many parts the whole is broken into. So this is called an improper fraction. An improper fraction is when you have a numerator that is greater than the denominator. So the numerator, my 5, is a lot larger than my 4, the denominator. Or not a lot larger, but it's larger than my denominator. So I can count this. I can say 1/4, 2/4, 3/4, 4/4, and 5/4. That's another way you can find it. Now, an improper fraction can also be represented as a mixed number. So a mixed number, you see this word mixed, it's mixed with a fraction and a whole number. So when we say whole number, we're talking about if we look at one of these wholes and we look at this whole, we want to see how many of these holes are shaded all the way in. So if we look at this one right here, I see that every single one of the 4 parts is shaded in. If I look at this one right here, I see that only one of them is shaded in. So the only whole number I have is this one right here. So I have 1 whole. I'm going to write it large. And then I still have to include what amount I see here. So here I see that I only have 1 out of the 4. So 1/4. So we've learned 2 ways that we can write a fraction. We can write it this way, or an improper fraction, or we can write it like this as a mixed number. Sorry, can't write and talk at the same time. Mixed number. All right, so let's look at some more examples. All right, so improper fraction, let's say I have 6/3, and I want to represent this and I want to put it as a mixed number. So 6/3, if you think about 6/3, you're thinking this numerator means how many parts I have, and this denominator means how many parts my whole is broken into. So if I have a whole, it has 3 parts, so 1, 2, 3. And I need to shade in 6 of them. So I'm going to shade 1 part, 2 parts, 3 parts. Uh-oh, I can't make any more. So that means I need to draw another hole. And I'm going to put this into my 3 parts. Now I can keep going. That was 1, 2, 3, 4, 5, 6. Okay, so I have 6 parts shaded, and the denominator tells me that each of the holes has 3 parts. So 1, 2, 3, 4, 5, 6 over 3. I can also see that 6 over 3 is the same as 2 because I have 1 hole here plus another hole equals 2. All right, let's do another example. Let's say I have 4 thirds. Again, this means that I have a hole, and my hole is broken into 3 parts, and 4 of them are shaded. So I can shade 1 part, 2 parts, 3 parts. Oh, I don't have any more parts to shade, so that means I need another hole. I'm going to make it have 3 parts again because I see the denominator's 3, and now I can shade in my 4th part. So 1, 2, 3, 4 is where this numerator comes from. 3 parts, 1, 2, 3, 1, 2, 3. That's where the denominator comes from. So now I can write this as a mixed number. I see that this hole is all the way shaded in. This part, and this part. It's all shaded in. So that would be 1 hole. This hole right here is not all shaded in. So this is why my mixed number, it's mixed with the hole. That's my hole. And it's also mixed with the fraction because here I only have 1 third. So 4 thirds and 1 third are the same exact thing. I could say that those are equal to each other because they mean the same thing. They're just represented differently. All right, let's try one more of these before we move on. All right, so here I have, let's say I have 7 and let's do 5, 7/5. So here again, the 5 tells me how many parts my hole is going to be broken into. 1, 2, 3, 4, 5. 7 tells me how many pieces I need to shade. 1, 2, 3, 4, 5. I need another hole, so I'm going to draw it as close to the same as I can. That was 5, 6, 7. Now that I've drawn 7/5, I can easily see that 7/5 is the same as 1 hole and 2/5. This right here, the whole thing is colored in. It's all shaded in. So that's where I got my 1 hole. And the 2/5 comes from here because it's 2 parts out of 5. So 7/5, 1, 2, 3, 4, 5, 6, 7 out of 5 parts, and then 1 and 2/5. All right, so here I'm going to give you some where you could practice on your own. So how about 8/7? What does that equal? 5/4, 3/2, 10/7. All right, so you can solve those and you can see what those would be. So if you want, I'm going to go ahead and give the answer. So go ahead, pause right here and see if you can get those. And then when you're ready, go ahead and push play, and then I'll have the answers to check your work. So when we're checking our work, I'm going to show you one other way that we can do it that doesn't involve drawing them out. It goes with what we learned with decomposing. So 8/7, I know that because the numerator is larger than the denominator, that I'm going to be able to pull out a hole. So if I look at my 7, the 7 tells me exactly what the hole is going to be. So the hole is going to be 7/7. This one has a 4. So I know that this is going to have a whole that's going to look like 4 over 4. This one here has a 2, so this is going to be 2 over 2. This one has a 7, so it's going to equal 7 over 7s. Now I need the rest of the amount because there's still a piece left here. So this one has an additional 1/7 because remember 7 plus 1 equals 8 and the denominator stays the same. This one right here with the 5 also has an additional 1/4. 4 fourths plus 1/4 equals 5 fourths. This one here also has an additional 1/2. 2 plus 1 is 3, and the 2's on the denominator all stay the same. This one here doesn't have 1 because we're at 7, so 8, 9, 10, it has 3 that are additional 7s. So now, when I want to write these, I'll change the color so you can see it better. When I want to write these as a mixed number, I'm going to take this one right here. This is the whole, 7 over 7. That means all 7 parts are shaded. So that's the same as 1 whole and 1/7. That would be my answer written as a mixed number. Here, 4 over 4, this is my 1 whole. I'm going to box it. So I'm going to say that this is equal to 1 whole and 1/4. This right here, 2 over 2, is the same as 1 whole. And then I'm going to add the rest, the half, and that's what that equals. This one here, 7 over 7, is equal to 1 whole and 3/7 is what's left over. So here you can, this is one additional way, you can draw it out, but this is one additional way where we can take what we learned with decomposing fractions and just work a little bit backwards. This time we're starting with our fraction and we're breaking it down. We're decomposing it to show what that mixed number would be. So this is just another way where you can find a mixed number. All right, so hopefully you got those correct and learned a lot reviewing mixed numbers, and we did some decomposing fractions and improper fractions. All right, thanks guys.